And this is a process. So let me do something here to remind people here. I'm going to say to you guys to recall nonlinear. Let's look at the phrase. Nonlinear, what that means is code for not linear. So, okay. Inequality. Well, we have various types. Less than, greater than, less than or equal, greater than or equal. And I want you to recall you had things that look like this that you guys had to solve. Now, this is called a linear inequality. Now, it's linear because the highest power is 1. So, okay, that was linear. You had this in beginning algebra. And you had to solve for x. And just remember from beginning algebra, you might say, okay, you had a 2x minus 1 greater than or equal to 5. You're solving that. You add 1 to both sides. And you get now 2x greater than or equal to 6. We're solving for x. So you divide both sides by that 2. You had this. X is greater than or equal to 3. And they would say, here's the solve portion. And they'll also say graph. So it's a solving graph. And we graph these kind of things. When you read this, we go to the real number line. The graph was on a real number line. 0's in the middle. 3 was to the right. We're shading numbers to the right. Numbers that are greater than 3 are numbers to the right of 3. Shade that. This is the graph portion. So, ladies and gentlemen, this is a linear inequality. And you say, but you just said we're working with here non-linear. Yeah, not linear. Then you might say, well, what does that mean? Here's what that means. You're going to solve and you're going to graph. But this time you have the following. X squared plus 5x plus 6 is greater than 0. Notice what you see. The power 2 means this is non-linear. In fact, this is quadratic. So you have a quadratic inequality. You say inequality? Yeah, because this is not an equality sign. This portion here is the inequality. So anytime you have a non-equals, you have these symbols here. You have a inequality situation, but it's not quadratic. We just simply say, for short, a non-linear inequality, and that's the name of the section. Non-linear inequalities. You guys have to solve these things here and graph. But this is new. So you might say, this is very new. It is. And so the technique we use to solve this is really called, I'm going to say this, you're going to use sign analysis. Sign analysis, ladies and gentlemen, solves this. And that's the lesson for today. So here's the process of sign analysis, okay? Here's what you guys are going to do. You're going to follow these steps. Number 1, solve the equality. You go, equality, Yeah, go back over here. You see this greater than? Here's what you do. X squared plus 5x plus 6 equals 0. This is what I call the equality because this is equal. And what you notice here is you're going to have a nice quadratic. And I'm going to ask you guys this. How do you solve quadratics? You should say, I know what to do. We can use the quadratic formula. We can complete the square because we solved quadratics in our life, power 2. And you could do that. You studied this. You're free to do that if that's what you want. But I'm going to say to you guys, when you solve the equality, I always choose 2-factor. And like the other day, they're going to make this factorable for you. Because you're really trying to follow a process. You're first learning a process, and then they give you these nice factorable trinomials, right? These quadratics that are going to be nice and factorable. So if you guys know how to factor, and hopefully you do, you're in luck. So I reviewed a little bit of factoring. You can never do enough factoring in your life, in my opinion. Remember, you have to find two numbers whose product is 6 and whose sum is 5. So if I start to color coordinate these things, right? Product here, this is positive 6. That's what you put here. And then maybe, I don't know, purple? Yeah. The sum has to be 5. It's this number here. So you need a product whose 6, whose sum is 5. You need two numbers. So let's ask you guys, what are the numbers? Let's see if you're awake. Let's see if you're back. What are the numbers? Thank you. And I put these numbers in red. They go here and here in the cross method or crisscross method. Thank you guys. Thank you so much. Yes, these are the numbers. You guys know factoring is just amazing. It's back. So here's what we do with this again. Remember, you got x in parentheses. Yes, it equals 0. You always use the numbers that you found here. This is positive 3 and this is positive 2. So you write it here. Positive 3, positive 2. So ladies and gentlemen, there you go. You factored. Now the reason you factor is so you can use the zero product rule. So you're going to use that zero product rule here. And you get, as a consequence of the zero product rule, there you go. You're going to get a straight line. You get your sheet of paper. Remember what we did. We said this first term times the second term. I think we used orange. Creatures of habit. Times that second term equals 0. That means either that first x plus 3 was 0 or the x plus 2 was 0. So you haven't solved these equations yet. You have to, oops. Okay. So I get x is negative 3, and I get x is negative 2. Okay, here's my two answers here. So you said, Mr. Judge, is this what you do first? You solve the equality? And I say, yes. And then you say to me, what do you do next? Well, the second step is going to be the following. I know we're putting in red. I'm going to say this. The second step is I'm going to say, use the values in step 1, found in step 1, to partition the real number line. So you can partition the real number line. Okay, so you'll say, what are the values we found? Well, I got 0 in the middle, so I know it means Okay, we found a -2 here. We have a -3 here. I'm going to put the 0 here and the 0 here above those values found. In other words, I got these numbers. X is -3, X is -2. I put the numbers here, I put this here. I always put the zeros because you found what's called the zeros. I'm also going to say to you, when you partition, this is what I mean by partition. Draw this imaginary vertical line through, X is -3 and X is -2. This creates, ladies and gentlemen, 1, 2, 3 regions. So you have what we call a partition of the real number line. And that's what we want. We want a partition. The only thing now is, we're going to make reference here to the product here. We have the product. It's x plus 3 times x plus 2. Remember, this is the original quadratic they gave us. Okay? Now, I want to remark here. I want you guys to know this is why you partition. Because step number 3, I'm going to say this. Use a test point to determine in each region to determine the sign of the region. So what we want to do is find a test point to determine the sign of the region. I have 3 regions here. 1, 2, 3. I need to know the sign of each one of these regions. So that's what's happening. Find the sign of a region. Now, a test point, ladies and gentlemen, is any number that's clearly in the region. So if I say to you, you know what? -5 is clearly in region 1, okay? Because it's a number that's to the left of -3. And then 0, my favorite test point, by the way, is clearly in region 3. So I found numbers in region 1 and region 3. The problem I have is region 2 in this question here. I need to use any number between the -3 and the -2. I'm going to use -2.5. This is going to be my test point, ladies and gentlemen. So a number clearly in region 2 now, because it has to be between -3 and -2, is about a 2.5. And I'm saying this is where it would be. Again, region 1, we're using -5. So the test points that we're going to use for every region 1, we use -5, region 2, -2.5, and then region 3, 0. We're going to test the sign of each region. And you might say, what do you mean by sign? We mean positive or negative, ladies and gentlemen. Positive or negative. That's what they want. A positive sign or a negative sign. We have to know, is region 1 positive or is it negative? Is region 2 positive or is region 2 negative? So we're going to try to find the signs of the regions. And you say, well, how do you do that? Well, go back here. You're going to plug in, ladies and gentlemen. I'm going to find purple. Your first test point. Plug it into the factored form. We're going to find the sign of the product. So -5 here plus 3 is -2. -5 plus 2 is -3. So now a negative times a negative is a positive. What this means, the test point of region 1, the value -5, is indicating that region 1 is positive. This is sign analysis, ladies and gentlemen. I got the sign of region 1. It's positive. Region 1's positive. So this is what we're doing. But we have to do this. We have to test every single region. Here, there's only 3. So the next test point, you say, what's the next test point? It's right here. It's negative 2.5. I'm going to plug that in to the product that I factored here. And I get negative 2.5 times our plus 3 is actually positive 0.5, so you guys know. And then a negative 2.5 plus 2, let me double check. Yeah, that's going to be negative 0.5. So I did the arithmetic here. Plug it in, plug it in. Negative 2.5 plus 2 is negative 0.5. So I have a positive times a negative. I don't care about the answer. I only care about the sign. So region 2 is negative. I don't care about the number. This is sign analysis. This is what we're looking for, the sign, either positive or negative. So the sign for region 2 is negative, while the sign for region 1 is positive. We go to the last test point. You say, what's the last test point? Since 0 was available, we're now going to test region 3 by plugging 0. So that 0 represents the region. So what you have now here, ladies and gentlemen, 0 plus 3 is 3. 0 plus 2 is 2. We don't care about the answer, but we know a positive times a positive is going to be positive. So I want you guys to take a very, very good look at this. This is known as sign analysis. We have knowledge of the signs for our 3 regions here defined by those values, negative 3 and negative 2. We know the signs. So you may say, okay, well, what does that mean for solve and graph? You told me to solve and graph this. We're learning sign analysis. How do I solve? How do I graph? Well, go back to the original question. And I'm going to say this is step number 4. Okay. Step 4. Answer the original question using the signs of each region. So your original question, I'm going to put it in black here. I think we had x squared, was it plus 5x plus 6, we say is greater than 0. Now, in order to answer this question, what this question is really saying is, where is this quadratic bigger than 0? And I want you guys to know, here's a definition. Here's what we say. A is positive if and only if A is greater than 0. You see, any number to the right of 0 is positive, ladies and gentlemen. This is a definition. So we know when A is positive. And then similarly, just so since we're on the, we can tell you what does it mean for A to be negative. A is negative if and only if A is smaller than 0. So these are kind of like tests for positive and negative numbers. So since we factored, let's go back over here. X plus 3, x plus 2 is greater than 0. Since we factored, ladies and gentlemen, what the original question really is saying here is, where is this product greater than or equal to 0? So I'm really going to say to you, what does this mean? Which quadrants, ladies and gentlemen, to be greater than or equal to 0, you got to be positive. Which quadrants are positive? use the picture. You earned it. You did sign analysis. You know the signs. Where do you see positive signs? Which regions? Which regions have positive signs, ladies and gentlemen? Region 1, Region 3. You say, how do I know? Because you guys are looking at it right now. These are positive signs, right? See this? So the answer to the question that I gave you guys is it's Region 1, Union, Region 2. Now, this is not how we answer the question, though. They want us to solve. They want us to graph. I'm sorry, not Region 2, Region 3. So if we looked at this, Region 1, Region 3, go back here. They want us to solve and graph. So I'm going to go back now, and I'm going to erase this information that's distracting us so that we can actually solve and graph, ladies and gentlemen. Okay, I'm still going to keep that reference, though, here, -3, -2, because this is going to be important. So I'm going to ask you guys this question here, okay? Since Region 1 and Region 3, what is Region 1? We have to solve and we have to graph this. Region 1, ladies and gentlemen, is all the numbers to the left of -3. That's Region 1, right? We partitioned that real number line. And Region 3 is all the numbers bigger than -2, Region 3. These are bigger. So you guys are looking at really the answer when you're looking at the sign analysis portion. Here's your final answer here, ladies and gentlemen. I'm taking the real number line here. Now remember, we're going through, we got -3, we got -2. Everything to the right of -2 is shaded. Everything to the left of -3 is shaded. Do we use parentheses or do we use brackets? Because this is a graph again. Parentheses or brackets? Let's take a look. We have strictly greater than here. That's strictly greater than. That means we don't use the bracket. We use parentheses. So, ladies and gentlemen, this is the graph portion. This is sign analysis. You solved it and you graphed it. And this is a very powerful technique to solving what's called nonlinear inequalities. The technique is called sign analysis. Now, it's a process. You have to follow these steps. I'm going to go to the browser again. I'm going to say, okay, browser, here's what I'm looking at. What I did for people here to start them off is I gave them problems that were already factored. So I'm going to look at number 2 because I know you guys have solutions to the odds. But I'm going to change number 2. It's not going to be exactly number 2. What I'm going to do is this small change. You got less than 0. And the good news is, let's put a big happy face here on this one. This one is already factored. Nice. So when I go through my steps of sign analysis, step 1 was to solve the equality. Since I don't have to factor, I say, okay, that's equal to 0. I got to solve this, the 0 product rule now. Tells me x plus 2 is 0, x minus 5 is 0. Subtract 2 from both sides, add 5 to both sides. You're going to get here now, x being -2. Here's my solution. solving by factoring. Here, x is positive 5 because you're doing the arithmetic on the right side, right? So these are the numbers that are going to partition the real number line. You guys have it right here. You're going to partition it. X is negative 2, x is positive 5. So partitioning is you're going to go back to that real number line. You say, here's my real number line. Here's 0, negative 2, positive 5. So the partition is defined by negative 2, positive 5. This is the values you found here. So draw a partition. It's an imaginary partition. It's like offices, people work in partitions. They're separated by a barrier. So here's our imaginary barrier. Partition, negative 2, positive 5. So it's already factored. Good. So let me ask you guys a question. Let's see if you're awake. What comes next in the process? Let's ask you. What do I do next in the process? Thank you. Thank you, Jim In. We use a test point. We got to test the signs of every region. So I have 3 regions. 1, 2, and 3. Thank you, you guys. Yes, we use a test point. Oops, where did that come from? We use a test point. Yes, thank you, Carmen. Yes, thank you, Valerie. We're going to determine the sign of every region. So we use a test point. Now remember, a test point is a number clearly in a region. So I'm going to use negative 4 as a test point for region 1. We're going to find the sign. 0 is available again. I love 0. I'm going to use that number. 0 is my test point. And any number to the right of 5. Okay, we could use 6. And, you know, we could use 6. We could use 7. It doesn't matter. You just can't use like 5 and negative 2 as a test point. They're the boundary. So you can never use the boundary. You have to use a value clearly in the region. So we're going to test the signs of each one. Now you might say, well, what do I use to test? Well, what are they asking? They're asking where this product is negative, by the way. So x plus 2, x minus 5. So we're going to take this x plus 2, right? X minus 5 here. Let's test the first region. So I'm going to take negative 4. I'm going to plug it in here. You end up getting negative 4 plus 2, negative 2. You end up getting negative 4 minus 5, negative 9. A negative times a negative. I don't even care about the answer. I know it's 18. I just care about the sign. My sign here is positive. Ladies and gentlemen, region 1 is positive. So I repeat the process now. I get to test region 2. And you say, how do I test region 2? You get to plug in now 0. 0 plus 2 is 2. 0 minus 5 is negative 5. Positive times a negative gives you a negative. Region 2, ladies and gentlemen, is negative. There you go, a negative region 2. We're going to get to test now region 3. Your test point in region 3, by the way, is positive 6. So I'm going to do some arithmetic here. 6 plus 2 is 8. 6 minus 5 is 1. So 8 times 1 is going to be 8. Region 3 is positive. So ladies and gentlemen, this is your test point values for each region. We found the sign of each region. We're now ready to answer the question, meaning the graph. So you say, well, what do I do? Well, draw a real number line. You have 0, you have negative 2, and then you have positive 5. Remember the question. You say, what's the question? They want to know, where is that product less than 0? Could you guys tell me, what does it mean to be smaller than 0 in terms of a sign? Which numbers are smaller than 0? Number is smaller than 0. What do you guys get? Less than 0? What does that mean? Anybody know? Less than 0? They're saying, hey, less than 0. What's the definition? Right up here. You are what again? Negative. Anything less than 0 is negative, ladies and gentlemen. So, which regions are negative? That's simple. Region 2. But you have to know, what is region 2? Region 2 are the numbers between negative 2, ladies and gentlemen, and positive 5. So you're going to shade the numbers between negative 2, positive 5. Look at that. Graphing is back. And since it's a strict inequality, strictly less than, you're going to say, use the parentheses. Ladies and gentlemen, here you go. You have now graphed this. Solve and graph. And there it is. And, you know, it's not in red. It's in, use a parentheses here. And there you guys go. You've solved and graphed. This is sign analysis. And just to say to you, just a note, by the way, if they gave you the same question, x plus 2, x minus 5, less than or equal to 0, the difference now is going to be the following. Here's the main difference. And I don't have to draw it to scale, but I guess I will. This is still the same sign analysis procedure. It's exactly the same. The only difference now is you have this portion equal. And you might say, what does that mean? Square bracket. So this is a note that if you have the inequality that involves equality, the less than or equal, then you're going to use square brackets. Even if it's greater than or equal, you use the square brackets. So just give you guys a quick note. And again, this is sign analysis. So it's nice if they already give you part of the information. I mean, it's nice if they gave it to you factored. And that's how I started people off on this process. I gave it to them factored. But if you have to factor, well, then you simply factor. So this is a sign analysis procedure that's very powerful in finding the signs of regions, where it's positive, where it's negative. And, you know, this is how we do things here with this powerful procedure. So I'm going to give you guys some examples to try yourself. I'm going to say you have x times x minus 3 greater than or equals 0. I want you to use sign analysis here. I want you to solve. and graph. And again, this is sign analysis. See what you get with that first one. And, we could give you something like this. X plus 1 times x plus 4 less than or equal to 0. And 3, x squared plus 7x plus 10 greater than 0. And number 4, x squared minus 4x is less than negative 3. So I want you guys to try some of these here for yourself. Let me see. Yeah, let's do another one, 5, just in case if we have some time. I say x squared greater than or equal to 16. Give you guys some time to do these here. Okay, so here we go. All right, use sign analysis, try these out. We may need to take a few more minutes for those. See what you get. Okay, we're back. So let's see how this went. So the first one we're going to do here, maybe we should cut these and move these out of the way. Okay, we'll start with that. All right, we're going to solve and graph. We're going to use really this new technique when we have a non-linear, not linear. We use called sign analysis. And first step is to solve the equality. So we say x minus 3, that equals 0. That's the first step. We get to now use our zero product rule. So this means x is 0. This means x minus 3 is 0. Remember that zero product rule we've been doing. This first term times the second term. That product is 0. That means either that first term equals 0 or the second term is 0. So we have to add 3 to both sides for this second one so that we can obtain a solution. We know here x is 3. Because the first one, when we set it equal to 0, was already solved. So that's nice. So these are their solutions here. These are the numbers that we use, ladies and gentlemen. And you say, how do we use this? We partition the real number line. We go through x is 0. And 1, 2, 3. So these are the numbers that partition the real number line. And again, I always put a 0 up here and here and draw my partition here through those numbers, 0 and 3. So I have region 1, region 2, and region 3. Those are my 3 regions. Using that, like we said, the solutions. And now we need test points, right? We got to test every region. We need a test point clearly in region 1. So I'm going to say, I'm going to use -3 as a test point. And now I need a test point in region 2. The problem is, and I didn't put 2 there. The problem is 0 is not available, so I have to use either 1 or 2, whichever one you like. I'm going to use 1 as a test point. And then I have 3, 4, 5. I guess I'll use 4 as a test point, ladies and gentlemen. And you might say, what are we exactly testing? You got to go back up here to the original product. We want to know where that product is positive, really, whether it's greater than or equal to 0, where it's greater than or equal to 0. So x times x minus 3, where is this positive? The test points will tell us. So I'm going to plug in a -3 for x, and we get -3, -3 minus 3, we get -3 times -6, and again, a negative times a negative is positive. That's positive 18. So ladies and gentlemen, region 1, we know, is positive. That's region 1. So we're going to do the same thing now. We're going to test region 2. We're going to use the test point we already decided. I guess I could keep it red. We use this test point of 1, so we plug in 1 for x. So we get 1 times 1 minus 3, or 1 times -2. And again, a positive times a negative will give us a negative answer, because 1 times -2 is -2. So region 2 is negative, region 1 is positive, and we have to test the last region, region 3. So let's erase the arithmetic. And again, we're going to use this number out here. 4, plug in a 4, and I get 4 times 4 minus 3, or 4 times 1, which is 4. So we know that 4 is positive. So region 3, ladies and gentlemen, is positive. So this is the arithmetic. Now you say, what do I do next? Next, we're ready for the answer. So the answer is found. We have to understand what that question is. So I'm going to go back here and put my 0 and my 3. And let's go back and look at this. They want to know where this product is greater than or equal to 0. Greater than or equal to 0. Being greater than 0 means it's positive. All right, so region 1 here is positive, region 3 is positive. So I just want to notate that we have to describe region 1 union with region 3. We have to shade, ladies and gentlemen. And I showed other classes this way. I say, hey, guess what? You're really looking at the answer here. There is positive, right? This is positive. That's really the answer. But I like to write it in a nice, clean, real number line, because you never see it, if you're looking back at the book. And again, because you have the equal sign. See this equal? You're going to use the brackets. So square bracket, really. This is what you see in back of every book. Even though you're seeing the answer here, include the 0. That's why we put here. Notate the 0 above there, because this is greater than or equal to. Greater than or equal to. Include 0. So all the information is in the sign analysis work you did here. So here's the sign analysis work, right? But you give your answer very cleanly on the bottom there in black. So that's solving and graphing, ladies and gentlemen. It's kind of like an OR situation, so you guys know. And this is the technique known as sign analysis. So let's try the second one. It's done exactly the same way. Okay. You just have to move some things out of the way. Okay, let's move it there. Okay. Now remember, you always start the process. You solve the equality. So you have x plus 1, x plus 4, and that will equal 0. This is the equality version. The zero product rule means the first term is 0 or the second term is 0. This is what happens when you multiply. So you say, what am I multiplying? X plus 1 times x plus 4. X plus 1 is 0. X plus 4 is 0. Subtract 1. Subtract 4. X is negative 1. X is negative 4. Both of these are solutions. So this is going to partition the real number line. This is how we use that piece of information. So we draw the real number line again. And we have to locate. I'm going to put 0 in the middle. I always do that. I like doing that. We've got to locate negative 1 and negative 4. So negative 1, negative 2, negative 3, negative 4 here. For these values of x, we get zeros. And this partitions the real number line into 3 regions. Region 1, region 2, region 3. So ladies and gentlemen, here's our 3 regions, x plus 1, x plus 4. We have to check the signs. Now, again, you say, what do I use to check those signs? You're going to use x plus 1 times x plus 4. But we need those test points. So we need to find a number clearly in the region, like negative 6 is clearly in region 1. We could have used negative 5. Maybe negative 2, clearly in region 2. And then my all-time favorite is 0, because arithmetic with 0 is the easiest arithmetic to do. So these are my particular favorite test points. I'm going to test negative 6, negative 2, and 0. I'm going to test every region. We're going to plug in those numbers. So when you plug in negative 6 here, you get negative 6 plus 1 times negative 6 plus 4. Negative 5, negative 2. Negative times a negative is positive. So region 1 is positive. So there you go, region 1. Now, region 2, ladies and gentlemen, we're going to test region 2. And you say, what point do we use? We're going to use negative 2. We already decided that. So negative 2 plus 1 times negative 2 plus 4 gives you negative 1, and then you get positive 2. Negative times a positive is negative. So region 2 is strictly negative. Test every region with your test points. That's all you're doing. The next test point for region 3 we know is 0 here. So we're going to plug in the 0. And 0 plus 1 is what we get. And 0 plus 4, we get 1 times 4, which is 4. Region 3 is positive, ladies and gentlemen. So again, take a look here. This is the sign analysis portion. And we notice again, what was this question here? This question is, where is this product less than? It's less than or equal to 0. Less than 0 means negative. Equal to 0, we know, is the same as 0. So what region is negative? Region 2, right here in the answer. Do we include 0? We certainly do, because it's less than or equal, so it's a square bracket here. So like I said, ladies and gentlemen, when you look at the sign analysis portion here, it tells you everything you need to answer the question to solve and graph a nonlinear inequality. But when you look in back of the book, you don't see, you'll see 0, -1, 2, 3, 4. You'll see square brackets here, and you will see this shaded because they like to give you a nice, clean, clear representation of the answer, and that's what's expected. So this is the solve and graph process. Your final answer is in a graph format. And there you go, ladies and gentlemen. Solve and graph. So that's what we're up to today. Now, if you look at question 3, question 4 here, looks like we're going to look at the last 2 here, just so you guys know. I'm going to get you started on some of these here, meaning they didn't give you a question that's nice and factored. So in that case, you need a factor. And I guess you want to bring out that crisscross method, right? Crisscross method from high school, people tend to love. I never seen it, but it's the same as the other method, actually. So we need a product of 10, a sum of 7, 2 numbers, multiplied together. 5, 2. So this will be factored as x plus 5 times x plus 2. And of course, don't forget greater than 0. So we're going to write this as greater than 0. So this is nice and factored, ladies and gentlemen. So again, the 0 product rule says x plus 5 is 0, x plus 2 is 0. We don't want to do that. First term, there it is, that's 0. And then we have over here x plus 2, that's 0, 2. Minus 5, minus 5. Minus 2, minus 2. And I get 0 minus 5 here will be x is -5. And over here we get x is -2. So ladies and gentlemen, those are the values we use again. To partition our real number line so we could determine the signs. So we know if I put 0 in the middle, I get -2 and -5 over here. So I like to put this notation of 0, oops, not at 0, at -2 and -5. So a 0 there and a 0 there. That's the meaning of using the solutions of x being -5 here, -2. The product is 0 there. And then I'm going to extend this. I don't have to, but trying to extend it. There we go. And like I said, I usually put it in purple here for your regions. Region 1, Region 2, and Region 3. So remember, we want to test the product, and the product is going to be x plus 5 times x plus 2. We need test points. We need points clearly in the region. So we're going to use here now -7 as a test point. I'm going to use also -4 as a test point, and 0 is available again. I love it when 0 is available. So notice my test points. Here's the values that define the partition, -5 and -2. And I guess put in red, test point, test point, test point. Plug those in. Now, I'm going to tell you guys what you'll get. You'll get positive, you'll get negative, you'll get positive. Double check this. Double check it. Plug in your test point values like we've been doing. You say, what do you mean? Plug in the -7, and I get -7 plus 5 times -7 plus 2. I get -2 times -5. Negative times a negative is a nice positive. That's for region 1. But I'm going to tell you what the signs will be. They're going to be what I just wrote down. So I'm going to have you guys test that for yourself. And then I'll say to you, we're in the answer step situation. They want to know where this product is greater than 0. Anything greater than 0 is code for being, what's the word? Positive. Only positive numbers are greater than 0. So which regions are positive? Region 1, Region 3. So I'll write that down. You have Region 1, Union, Region 3. So ladies and gentlemen, here this is. Oops, we got rid of that. -5, -2, numbers to the right, numbers to the left, and again, they're strictly positive. There's no equality there. So parentheses here and here. Anyway, so ladies and gentlemen, here is the solving graph portion. This is what you guys do. Solving and graphing. We're using sign analysis. All right, here we go. Now, be careful with the next one. You see, ladies and gentlemen, you don't have greater than 0. You don't have less than 0. You don't have that here. You got a number. What we need on that side, instead of a -3, we need a 0. So we're going to add 3 to the right and add 3 to the left. X squared minus 4x plus 3 will be less than -3 plus 3 is 0. So now, ladies and gentlemen, now we could use a procedure called sign analysis, so you guys know. And that's what we learned. And then if I said to you, what about the next one? Notice the next one is the same here. You got a 16 there. You need a 0. Well, you can fix that very easily. Subtract 16 from both sides. And what you end up with is, here's what you get. X squared minus 16 is greater than or equal to 0. So now, again, we'll say, what do you do with this? Sign analysis. Oops, doesn't seem to want to do a square there. Sign analysis is what you do here. So, okay, but this is not factored. So what do you do then? We have a quadratic, a trinomial that's not factored. You got to factor. Same thing here. You got another one. You got to factor here. All right. So sign analysis requires us to have a factored version because we have to solve this thing. And so you might say, okay, right? So really at this point, right, we factor that. This is x squared minus 4x plus 3. We solve the equality, so I have to factor. Remember, the product here is 3. Negative 4 is my sum, because we've been saying this number here is your product. And I don't remember the color, maybe purple, I don't know. Negative 4 here, right, is the sum. We need two numbers multiplied together whose product is positive 3, but whose sum is negative 4. That's negative 1 times negative 3. Negative times a negative is positive. Negative plus that negative is also a negative. So this is what we get when we factor. So you guys know this will be x minus 1 times x minus 3. This is the equality. You have to solve this. So I'll say solve this. And then similarly, you say, what about this one? I just want to remark about this one. I can say that 0x squared, ladies and gentlemen, minus 16, because 0 times anything is actually 0. And remember, we're solving the equality. We're doing step 1. So when we factor by the crisscross method, the product is negative 16, and your sum is 0. So we got that negative 16, and we have 0 for the sum right there. We need two numbers multiplied together. Negative 4, positive 4 gives you negative 16. Notice when you add them, it gives you 0. So I can use the crisscross method in this case. X minus 4, x plus 4. We actually factored here. So we're going to have to use these versions here to solve. But I wanted to go over a bit of that factoring for you guys so you can finish the rest of those. I can even tell you what this will be. I can even give you the answer for this last one. The answer for the last one, they want to know where this is greater than or equal to 0. Here's your solution. You guys can verify this. And I guess we have to have a bigger line here. So for the last one, zero, 1, 2, 3, 4, maybe 4 here. Oops. One, 2, 3, 4 over here, negative 4. I'm going to tell you what this one is. You're going to have brackets. And final solution will be these here. All right, just to let you know, there's the answer for that one, but go through the sign analysis. That's what this is. And then you might say, what about this other one? Well, let me cut everything here. I guess we have to do this. Yeah, let's do it that way. Let's cut it. I like that feature. I can tell you what sign analysis will give you here. Let me just read it. Negative less than 0, negative. Okay, less than 0, negative, 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 negative. Between what numbers? Positive 1 and positive 3. So 0 is here, positive 1, 2, and 3 here, and we're looking for the numbers that are going to be negative. This is between, and we have parentheses here. So when you guys go through and do sign analysis here, you guys are going to come up with these solutions here for them. And I just wanted to kind of go through how you go about some of these at least, okay? Alrighty, here we go. Here's what's happening here with this, so you guys know. Let's go back and take a look to see what exactly we are doing here. Go to the browser. We did graphing quadratics. So part of your homework from that web will be graphing quadratics. You want to do them all. And not only did we do graphing quadratics, if we go to the next one, we worked on some of these nonlinear to 48, these kind of questions. Because we have to work on sign analysis for those rationals. And it's very simple. So I'm going to continue here. So your homework's going to be really now all of them, after we complete this. So we have what's called rationals. Remember, whenever you see that word rational, it's fraction. And you have these rational, we'll call it equations or inequalities, because they are inequalities. I'm going to start with the word rational really means fraction. And a fraction looks like this. It's A over B. So for example, if you have x over, and we can do it, we can go to a little bit more. Let's say I have x plus 1 over x minus 2. And they want to know where this thing is greater than 0. So here's an example we're going to start with. Now, the reason it's rational is because it's a fraction. And the procedure that we went through yesterday, the first steps was, if you guys remember, that step 1 was to solve the equality. And so the equality is x plus 1 over x minus 2 equals 0, right? So that was kind of the one that we talked about. But what I'm going to say to you, I'm going to replace this fraction idea with a numerator over a denominator, right? Triangle over square. You say, why do you go to the shapes? Because in the shapes, what you can have here, right? So here's really the first step, and I'll put this in words for us. I'm going to say step 1. You're going to solve the equality and find where the fraction, rational, is undefined. So there's really two things here. Solving the equality is what I started to write down here. So here's those two things. You have x plus 1 over x minus 2 equals 0. So that's the first thing we have to find. And we also have to find where x plus 1 over x minus 2 is undefined. And that's what I mean when we say solve the equality, solve where it equals 0, and actually solve where it's undefined. So I want to really emphasize this, that that's 0 is what we're talking about. And I want gray. And then I want undefined. And so that's kind of where we start. But it's simple, but we have to know a few facts here. So here's a few facts. few notes. I don't know. We'll use purple. I don't know. Here's what I want to say. The two notes we have to use. If a fraction in your life ever equals 0, then you know what that means? It means the numerator was 0. So we're going to use this statement here. So I have a fraction equal to 0. So on the left, when they say to you, you have two things to do on the left. They're saying this must be equal to 0. So we say x plus 1 is 0. That's what they're saying in that fact. And then maybe we should do this. Let's cut this. And then we have another fact. I'm going to say, if you have a fraction, and remember this is a little different, where it's undefined, then that happens where the denominator equals 0. So these are the two things we have to find. And now you say, oh, to be undefined, I let the denominator equal 0? Yes. So for these two things now, we're going to let now the denominator x minus 2 equals 0. And this is what we need to find. So we have to find where that numerator is 0 and where the denominator is 0, because we're dealing with a fraction, and fractions equal 0 only if the numerator, the number on top or the term on top is 0, and it's undefined. We can't divide by 0. So it's undefined. So this is kind of where you start always. Now, we haven't solved yet. We have to find those values of x, right? This is going to be what we use. Subtract 1, add 2. So we end up here with x being negative 1. And we end up being here, x is positive 2. These are the values that we use on the real number line. And so remember what we did yesterday. We said we have to use those values for the fraction. Yes. See, but we're going to label what these values mean. And if we can, okay. We need negative 1. We need 2. So remember, I like always indicating where 0 would be, right in the middle. Negative 1 is to the left, and positive 2 is to the right. So let's keep track of what this means. Right, we have the fraction. This is what we're going to have to test the sign for. X plus 1, x minus 2. Remember, when x is negative 1, we put the 0 here, because for that value we get 0. We solve this equation. And when x is positive 2, the fraction is undefined. So I don't put 0, I put u for undefined, because this is what we are using here, right? When x is 2, the fraction's undefined. When x is negative 1, the fraction is 0. That's what we're looking for. So this is going to define for us the partition that we were looking at yesterday. So we're partitioning here and here. And let's make sure that's through 2. So this gives us region 1, it gives us region 2, and it gives us region 3. So remember, we need a test point for each region. So a test point, and this is to answer questions that have come in from some of you guys. A test point is any number clearly in the region. And you might say, what do you mean? Well, region 1 is all the values here that are smaller than negative 1. So you give me a number smaller than negative 1, any number. You can say, can we use negative 3, right, as a test point? Yes, you can. Because that's clearly in region 1. So any number smaller. Okay, so it's clearly in region 1. We're going to test region 1 with that number. And again, you might say, I know your favorite test point for sign analysis is 0 because the arithmetic is so easy with 0. 0 is available. 0 is clearly right in here, region 2. It's between -1 and 2. That's what region 2 is. And so now, for the third region, you might say, can I use +5 as a test point? Yeah, you can actually use any number clearly in region 3. Numbers that are bigger than 2 are region 3. Don't use 2 because 2 is not bigger. So this is how you find your test point. It could be 4, it could be 3, it could be 3.5. So you are free here to choose your test points, and that's fine. The test point is going to determine the sign of the region. So here's what we mean. We plug in -3 here. So we're going to test region 1. This is the test here for this region. We're going to plug in the -3 test point, and we do the arithmetic. -3 plus 1, -3 minus 2. And -3 plus 1, that's -2. -3 minus 2 is -5, and a negative over a negative is a positive. So region 1, the test point of -3 tells us region 1 is positive. So I just put my positive signs here, ladies and gentlemen. So that's the test point here. And then you might say, what about region 2? Well, we have to change the value. Use the test point we decided to use 0. So I'm going to use 0 here. So I get 0 plus 1, 0 minus 2, positive over negative. Well, that's a negative. So region 2 here is negative. So we're indicating that it's a negative region. We now use the test point of 5. We're going to see what that becomes. So the test point of 5, we get 5 here, 5 here. I get 6 over 3, which is 2. It doesn't matter what the value is. What matters is the sign. And so, ladies and gentlemen, here, this is the difference here between a product and a quotient. The real difference is right in here. That when x is 2, the fraction's undefined. When x is -1, the fraction's 0. So that information is going to be very helpful for us in deducing our answer. So here's our sign analysis, ladies and gentlemen, for a fraction. Okay, so we found the signs of every region. And then remember the next step. You say, well, what was the next step? Well, go back to the original question. They want to know where x plus 1 over x minus 2 is greater than 0. Right? They want to know where this fraction here is bigger than 0. And let's ask you guys, let's note, or here's the question I'm going to say. What does greater than 0 mean for any really term? And I gave you a definition yesterday. I put A. I know it's a different A because I know I said, okay, A over B. So how about if I just say this? What does that mean? It's kind of the same thing, right? What does that mean? Does anybody remember from yesterday? What does it mean to be greater than 0? It's pretty loud. Yes. Thank you, Jimin. Thank you. It means it's positive. That's what that means. So when you see bigger than 0, they want to know, where is this fraction positive? Thank you, Carmen. And go back here and essentially you go, oh, I know. It's really region what? It's region 1 united with region 3. That's where this fraction is positive. But remember what they'll always say to you. They're going to say solve and graph. So the instructions were earlier above, solve and graph. When we did the products, we're not doing the quotients. You got to solve and graph this. And like I said before, where is it positive? For these values of x. Region 1 is everything to the left of -1, and region 2, everything to the right. So you're really looking at the answer. But be careful, because this inequality is a strict inequality. It's strictly greater than. There is no equal. Then we have to use the parentheses here. But when you're looking back at the book, right, when they have you do this, they have you look at a very, very nice, clean graph. They go, okay, you're going to have this. Here's 0, 2. Here's -1. And ladies and gentlemen, everything to the right of 2 and everything smaller than -1. That's the solution, very clearly, very nicely. But as you guys can see, or as you guys can deduce, right? There we go. Here's our solution. All the work is right up here. So I want to point this out. There you guys go with this answer. So it's just like what you did, only you have a factored term as a numerator and one as a denominator. And then I'm going to say here's a by the way. This is going to be interesting. Okay, so here's a by the way here for you. If they gave you that same problem, said, what was it? Oh, x plus 1 over x minus 2. But now they want to solve and graph. You already solved it. All the sign analysis is done. But notice the difference. The difference is the inequality is greater than or equal. It's greater than or equal. That means you have that equal sign. So I'm going to go back again here. Here's what I'm looking at. I'm looking at, you already know what part of the answer is. And what's going to change, ladies and gentlemen, is these endpoints. So where it's positive, we're already shading. But what is the meaning here of the equal sign, right? You got this equal sign. What does this mean when you have that equal portion, right? Because this is greater than or what? Equal. Kind of like you said plus or minus. Well, that's a greater than or equal. We already dealt with the greater than. So what I'm saying to you is, what does it mean to equal? How do we describe that answer? Well, go look at what work you did. I want you guys to notice something right here. When x is -1, doesn't it equal 0? Right? When x is -1, doesn't it equal 0? Let's focus. When x is -1, doesn't it equal 0? The answer is yes. So what that means, ladies and gentlemen, I have to change this endpoint. That has to be a square bracket, because what you're saying now is please include -1, because this fraction is greater than or equal to 0. Now, here's the next question. Go look up here. I don't want to do that. I don't know what I would do without the undo. It seems to automatically go to erase a lot. Here's my question to you guys now. What about the 2? Do I put a square bracket around the 2, or do I leave it as a parentheses? So here's your option: square bracket or parentheses. What do you think you do? Square bracket or parentheses? What do you think you guys have? Thank you, Carmen. Absolutely, you have parentheses. You guys know why you have parentheses? Yes. You have parentheses here, ladies and gentlemen, because when x equals 2, the fraction's undefined. Undefined means not defined. So you're done. In other words, if they change it to you to have the equal sign, then you only include the -1, but you don't include the 2. So I have 0. I got -1. I have 2. And this is the final answer when you shade. So it's only around the first one. That's the difference here. So I wanted to show you guys the difference. Absolutely. Okay. Let's double check. Okay. Yes. Parentheses. Absolutely. Yes. All right. So, ladies and gentlemen, this is your answer when they have, hey, include. But remember, this is why we want to know where it's undefined as well. Okay. Good. Good. So let's try another one. See what happens here. Let's try another one so you guys know what this. Those are all the details. Okay. Let's give you guys another example here. They can give you something like this. X minus 6 over, how about just an x, and they want to know where it's less than or equal to 0. So we're going to go through our procedure. Remember, you can go straight to something like this. We need to find where the fraction equals 0. Well, we know that happens when the numerator is 0, so x minus 6 has to be 0. We need where the fraction is undefined. And you say, oh, I know that happens when the denominator is 0. So remember, oops. Numerator is 0, set that equal to 0. Denominator has to be 0. That's what they're talking about. So in the first case here, we get to add 6 to both sides, and then we end up with x being positive 6. We're going to use this. Here, by setting the denominator equal to 0, it was already solved. So I just want to let people know that's your first step here. And the importance of this is to find where it equals 0 and where it's undefined. So we go to our real number line, and we have to plot the information here. So we're going to say, I'm going to put 0 here. And this won't be to scale. 1, 2, 3, 4, 5, 6. Maybe we'll put it to scale. I'll put 0 here. And we say 1, 2, 3, 4, 5, 6. It doesn't have to be to scale, but anyway. Now we're going to put the information. When x is 0, right up here, x is 0, this is undefined. That's why you put a u. And when x is 6, the fraction 0. There we go. So we're going to do our sign analysis procedure. This is the first part of it, though. Okay? You find where the fraction 0, put the value of x for where it happens, and list the information. Notice what I did, because I might have to use this piece depends on my inequality sign. So that's there. I now have test points because I have to test every region. I have region 1, 2, and 3. -2, test. Maybe +2, that's clearly in region 2. And then maybe I'm going to say, I don't know, 7, that's clearly in region 3. So you're going to use values clearly in each region to test the region. You're testing the sign. Now, the fraction they gave you, the information that you use to test, right, the x minus 6 over 6, you're going to have to find where that fraction is positive, negative, based on the test values. So there we go. Let's try to test the -2 here, right? So plug in -2, -2 minus 6 over -2, -8 over -2, and a negative over negative is a positive. So region 1 is positive. And at this point, you may say you want to test now +2, right? Because that's going to be region 2 right here. Test +2, 2 minus 6 over 2, -4 over 2 gives you -2. Oops, let's go back there. So region 2 is going to be negative. Test region 3. 7 gets plugged in. So I get 7 minus 6 over 7. I get 1 over 7, again, a positive answer. So here you go. So ladies and gentlemen, that's sign analysis. This is all the information you need to start to graph now. So we have to graph the solution. Okay? Okay, we got some good questions based on some observations here. Okay. Carmen, when you first learn this process for sign analysis, right? A lot of these questions, except for some that I'll go through for you, generally speaking, well, there's a couple of ways to answer this. Generally speaking, the answer is no. It's not always going to be positive, negative, positive. I can understand. You guys are going to know, Mr. Judge, I did 40 of these, and I always got positive, negative, positive. Isn't that always happening? Well, generally speaking, no. But when you first learn the process, yes. Because the problems they give you, they're so specially chosen with this, that pattern does happen because it takes some time for people to learn this process. And it's such an important process because you guys are going to be taking other math classes that may be using this process in your future. And when you step up to those classes and you start taking the work in those sections, you're going to see it's not always positive, negative, positive. It could be negative, positive, negative. In fact, this process can be negative, negative, positive, but that's in other courses. So the technique you learn in 125, yeah, you may say, guess what? I've done all this homework and it's positive, negative, positive. And I'll say, yeah, probably 90% of it, if not all. I'm going to show you some variations soon. But it's not, it's only because you're first learning it. And yeah, they give you these specially chosen questions. I can change things very easily and make it different. But when you first learn it, that's kind of not what you want to do. You want people to kind of go through this and say, oh, okay. And you want people to learn definitions like the fact that this now means less than or equal to 0. So we're going to try to graph this and, what does less than or equal mean? Well, less than 0, any fraction less than 0 means the fraction is negative. So you say, well, where's my fraction negative? Well, your fraction is negative in region 2, right in here. That's the whole purpose of sign analysis. Region 2 is the negative region. Now, the only thing that's left to deal with is this equal to 0 down here, the equal 0. Right there. And equal to 0 happens only when x is 6. This is why you looked at and labeled that as a 0. Don't use undefined. Undefined is just that. You're not defined. So when you graph here, you're going to include 0, but you're not going to include, you're going to include 6, but you're not going to include 0. Because when it's 0, the fraction's undefined. Undefined means not defined. So you're looking at the answer here, everything between 0 and 6. But yes, Carmen, it looks like pretty much for a lot of these questions you guys get in 125, that's the same pattern you see over and over again. And so I would say, yeah, probably 99% of the time, you're going to have that region, be what you're saying. You're going to see the positive, negative, positive. Anyway, and this is the graph portion, so you guys know. So you solved and graphed. So that's kind of what's going on here with this morning, these fractions here. So, I mean, I hope I answered that question. Are you guys okay with that idea? That the difference here is you have to find where the fraction's undefined because it could be part of the answer or not part of the answer. Okay. All right, I'm going to give you guys a couple of things here. Let's try something like this. And to give you guys a few minutes to try this kind of example. X plus 1. So I'm going to give you a couple of minutes to try something like this. X plus 1 over, you got x minus 1 over x minus 2 is greater than 1. And the second one, x plus 2, x squared plus 5x minus 14 is greater than 0. Let's say greater than or equal to 0. And actually, I'm going to change this one on you guys. Sorry. Put less than 1. And I'm going to give you a hint on number 1 here. X minus 1 over x minus 2 being less than 1, we have to have the right side be 0 because we're trying to find whether the fraction's positive or negative, and that definition is only in terms of being 0 there. So you're going to have x minus 1 over x minus 2 minus 1 now. Now it's less than 0. So that's how you start number 1, so you guys know. And then I might say to you, what do you do now? Here's another hint. This is a fraction. How have you guys, if you remember how you subtract fractions, you need to have the same denominator. So the denominator that has to be the same here is x minus 2. So I'm going to put an x minus 2 down here and an x minus 2 up here. So here's a big hint. And then now you say, does that mean I have x minus 1 minus this x minus 2 here, everything over that x minus 2? Or we can do it this way. Let's do it this way here. Let's not skip a step. X minus 1 over x minus 2 minus the x minus 2 over x minus 2. That's less than 0. So notice something here. You have the same denominator now. Now you can subtract the numerator. So you have x minus 1 minus the x minus 2, everything over x minus 2. And that will be less than 0. So I'm going to say to you guys, distribute x minus 1 minus x plus 2, and that will be over x minus 2. And that's less than 0. So we can combine like terms. And so, ladies and gentlemen, notice the cancellation here, right? You have an apple, you owe an apple, they're gone. You owe $1, you have $2. The numerator is 1. So this is what we do with sign analysis. This is what we use. So if you have a number out here like this one, that question number 1 is really going to be 1 over x minus 2, because that needs to be less than 0. We need to have 0 there. So this is really 1 over x minus 2 is less than 0. So this is the hint. It's actually a lot more than the hint, but I want you guys to do sign analysis for these two, and I'll give you guys some time to do that. Okay. So sign analysis, we'll give you guys, let's get out the clock and see what you guys can get for these, doing sign analysis. And we'll get you started. Okay, here we go. Let's try something out. These are kind of interesting, so I wanted to give you that twist there. 1 over x minus 2 being negative, that fraction. So I want you guys to know, here's what you would do. Here's how I think about that. Remember that first part. Set that equal to 0. And set the fraction equal to being undefined. And in the first one, we set the numerator equal to 0. So we say, oh, 1 is 0. The next one, we set x minus 2, right? It's undefined. So we're going to say x minus 2 has to be 0 here. So this is the information. We followed the steps there. However, we know that 1 could never be 0. This is a false statement. This is not true. So in other words, here's what this means. The fraction of 1 over x minus 2 could never equal 0. See, it doesn't matter what value of x we put in the denominator. X could be -3 and we plug it in. X could be 0 even, and 0 minus 2 is -2. The fraction here, when you have a constant on top, right, with that constant's positive, it'll never be 0 here. So we have a constant equal to 0. This never happens. And so it could never be 0. So that's good information. So this fraction's not ever going to be 0. However, if x is positive 2, because we're solving this, when x is positive 2, the fraction is not 0, it's undefined. So we only have one value to consider here, and that's the value x is 2. So when we do this, you say, okay, here's my real number line. And you say, oh, okay, let's see, there we go again. I'm going to place 0 right there in the middle. Here's where 2 would be. I'm going to label when x is 2, my fraction's undefined, because we know that. There is not a location here where the fraction is ever going to be 0. So I got region 1 here, and I have region 2 here. So this problem has only 2 regions. That's fun. So I pick a number clearly in region 1. Since 0's in region 1, I'm going to use that as a test point, and then I'm going to use maybe 4 as a test point. And so remember, we're testing the fraction here now. 1 over x minus 2. So we're going to plug in the value of t being 0. So you get 1 over 0 minus 2, which is 1 over negative 2. Positive over a negative is a negative fraction. So region 1 here is negative. So this reminds me, Carmen, of the question, is region 1 always positive? The answer, generally speaking, is no. Here's an example where region 1 is negative. So, you know, we can have some variations of things. The second we start varying things, then you can have different results. So here's a situation. This is not positive, it's negative. So if you jump to say positive, you might get that wrong, right? So you do have to test it in the next region. We're going to plug in for the test value of 4. So I have 1 over 4 minus 2, which is 1/2. And sure enough, that region is the opposite. It's positive here. So we have all the signs for the region. Okay, good. All right, so originally they're asking us to be less than 0, right? So we want to know being less than 0 means the fraction is negative. Anything less than 0 to the left of 0 is negative. So the fraction is, let's go and change that. This is region 1. The fraction is negative in region 1. All the numbers to the left are 2. So you're looking at the answer. And then you say, well, is this a strict inequality? And the answer is yes. So because it's a strict inequality, there's no equal. You're going to have that parentheses. So a very, very clear graph of this. Very clear. Even though you say, here's my 0, here's 2, we're going to put parentheses. We're going to sketch this. I'm going to shade all the numbers to the left of 2. And so, ladies and gentlemen, here's the graph here of this first problem. And there you go. So that's a good one. Okay, so there we go. Yes, we had to make that 0 by doing a little bit of algebra. And then I have x plus 2 over x squared plus 5x minus 14. So x plus 2 and I think that was less than or equal to 0. Let's double check. Yeah. Oh, no. Greater than or equal to 0. All right, this is going to be interesting here, ladies and gentlemen. So remember what we're using here. Let's write this down. We want to know where, excuse me, where this fraction equals 0. Or where the fraction is undefined. Now, the fraction is 0 when that numerator is 0. So we say x plus 2 must be 0. And then the fraction's undefined when the denominator equals 0. So we say x squared plus 5x minus 14 is 0. So that's going to give us an undefined situation and where we're equal to 0. So we have to solve for x. In the first one, we simply subtract 2 from both sides, and we're going to get x is negative 2. So this is for the first one. So we know this is going to give us where the fraction equals 0 when x is negative 2. The next one, though, you might say, oh, we have to factor because this is a quadratic equation, right? So we go, oh, boy, quadratic equations show up a lot everywhere in life. They sure do. So when you go through your factoring technique, I mean, you can certainly solve this quadratic by using the quadratic formula, even by completing the square. But if it's factorable, then factor. That's my model. I think factoring is actually quicker. And then here we use that zero product rule. So this means x plus 7 is 0 and x minus 2 is 0. So we can solve these for x. So we get x is negative 7. And here we get x is 2. Now, these are the locations where my fractions are undefined. Remember this. This is about being undefined. So remember this. This is the undefined values of x there, and this is where it equals 0. So we're going to use these numbers. So at this point, ladies and gentlemen, label everything. So you go, oh, I have my real number line. Now, look, take a look at the numbers. You got negative 2, you got negative 7, and you got 2. So if you put 0 right here, here's 2. The fraction is undefined. Here's negative 2. With negative 2, the fraction is 0. Then we got 3, 4, 5, 6, 7. I'll put negative 7. The fraction here when x is negative 7 is undefined. So I want you guys to really keep track of that because this is the reason you did the first part. This is why you solved the way you did. So double check, right? If we said, okay, when x is negative 7 and positive 2, here's positive 2, here's negative 7. This is the undefined part. When x is negative 2, that makes it 0. So now, if you'll notice here, if we partition the way we've been doing, we don't have 3 regions, we have 1. We have 2. We now have, what, 3. You got 4 regions here. We got 4 regions to test on this question. So we need to get out some test points. So any number to the left, negative 9, I'm going to use negative 9 as a test point. Anybody to the left, any number to the left of negative 7 is in region 1. Any number between negative 7 and negative 2, like negative 3, 4, maybe negative 5 here, that's in region 2. Any number between negative 2 and 2. Oh, 0 is available. I'm going to use that. Any number to the right of 2. 3, 4. I got 4 test points because I have 4 regions. So you're free to pick these test point values. You might have picked different numbers. That's fine, as long as they're clearly in the region. And then I'm going to suggest to you guys to do the following, right? Remember what this fraction is. You got x plus 2 over, use the factored portion. I know it's down here. This is x plus 2 over x squared plus 5x minus 14. I'm going to say to you guys, use the factored version right here. And then you say, what's the factored version? It's right here. X plus 7 times, so here's what you guys want to do. X plus 7 times x minus 2. Use that version, and I'll show you why. If you use the factored version, that's going to make your arithmetic a lot easier. Okay, so x plus 7, x minus 2. It's going to make this easier. Let me show you what I mean. The test point is -9. So I'll plug a -9 in. So we have -7 over -9 plus 7, that's -2. And then -9 minus 2, that's -11. So ladies and gentlemen, you have a negative divided by a positive. And let me say this, you don't even need to do the arithmetic. You just pay attention to the sign. So now it's a negative over a negative. I'm sorry, negative over a positive, right? I know it's 7 over 22, but I'm just looking at the sign. So region 1 here, a negative over a positive is negative. Region 1's negative. Whoever said you had to start with a positive region? So these are the curves that I'm showing you guys here. As soon as you change a few things, you know, you see something different. So now we're going to try -5 there. Let's plug it in. -5 for x. We'll get a different set of arithmetic. So here's what we get. -5 plus 2 is -3. -5 plus 7 is +2. -5 minus 2, that's -7. Again, I don't even pay attention to the numbers, just the signs. Because I'll have a negative over a negative, and that will give me a positive. So region 2 is positive. Okay. The next test point. My all-time favorite test point, 0. So if I plug in that 0 there, we get 0 plus 2, which is 2. 0 plus 7 is 7, and 0 minus 2 is -2. So I don't even care about the value. The sign, I got positive over a negative, will give me a negative. We're just looking at the test points. So that's why I love 0. The arithmetic's always so easy with 0. So we're going to say 4 now. That's our next test point, right? So we're using these test points. Right? We use 0. Now we use 4. 4 plus 2 is 6. 4 plus 7 is 11. 4 minus 2 is 2. I don't even care about the value. I just care about the sign. They're all positive. So when I multiply, I get positives. When I divide, positive is positive. Region 4 is positive. So here's our sign analysis, ladies and gentlemen. Check the signs. But the original question, remember, they want to know where this thing is going to be greater than or equal to 0. Now, greater than 0 again, any fraction that's greater than 0 means that the fraction is positive. So you look for the positive regions, region 2 and region 4. Now, region 2, these values of x will make the fraction positive. And this is region 4 right here. These are the values of x that make that fraction positive. So you got this region 2, region 4, or the positive regions. And then you say, oh, okay, well, what's the meaning down here? It's not just positive, right? This is equal. because this is the greater than or equal to 0. So greater than 0 or equal to 0. So we know where it's greater than 0, but I'm going to ask you guys where or what values of x make this equal to 0. What values of x make this equal to 0? Anybody know what values of x make this equal to 0? Thank you. It clearly happens. Thank you, Jimian. It clearly happens right here. When x is negative 2, the fraction is 0. That means put a square bracket. And you say, what about negative 7? You're going to put a parentheses because you don't include negative 7 because this is undefined. It's not 0. 0 is defined. You put a parentheses here. Why? Because at 2, this is undefined again. 0 is very much defined. They're not the same thing. So it only happens at negative 2. So thank you, Carmen. Thank you, Jimin. Thank you, Janelli. It only happens at negative 2. So you're really looking at the answer. If we try to clearly, draw all this. Zero, 2, negative 2. Only bracket around the negative 2. Parentheses around this. So ladies and gentlemen, there you go. Here you go. There it is. Okay. Thank you, Janelli. Thank you all. And that's how you do, some of these sign analysis questions. Anyway. Okay. So I guess here's what we're going to do. This is a good time for a break so we can transition. So I'm going to give you a break earlier today. Have an earlier transition. So as you guys know, what I'd like you to do now is simply, print your name so that we can know who's here, who's not here, right? It's about taking roll here. So print your name, and then when we come back, we will go over some other concepts we want to do. And, yeah, let's start to take a break here. So print your name, ladies and gentlemen, and we'll see you in about 25 minutes. Thank you.